Acha, the problem, have you solved it? Anyone of you have solved the problem? Pritam, Vidisha. Did you solve this problem? So let us say, consider the set of processes. Are you able to hear me? Are you able to hear me? Rahul, Pritam, Vidisha,
Yes,
Tripura.
sir. Yes, sir. We can
Problemটা
hear
solve
you.
করেছো? Problemটা solve করেছো? Rahul, have you solved the problem? Vidisha, have you solved the problem? Pritam, have you solved the problem? হ্যাঁ কি নাতে উত্তর দাও বাবা। উফ, আনমিউট করে হ্যাঁ কি নাতে উত্তরটা দিয়ে দাও। Okay. So I'm presuming that none of you have solved it, right? Okay, let us solve the problem. So let us say this is the process, right? So we see in here all the things are there. Consider the set of processes of variable time in milliseconds, CPU burst time in milliseconds, priority 0 shown below. None of the processes have the IO burst time. The average waiting time is this one. So I presuming that this is a preemptive short time algorithm, priority short time algorithm. Let us solve this one. So at initially P1 was there initially 0, right? Its priority is 2. So let us say 0 is the highest priority, right? After P1 came, so its arrival time so let us say P1 came, right? So its arrival time was 0 and it waited for around 2 milliseconds, right? Why it's waited for 2 milliseconds? Because after that P4 came and its basically a priority was highest, right? Priority was highest than P1. So P4 preempted P1. So P1 was left aside, right? So how much time left? 9 milliseconds left, right? So now P4 now came and it has a burst time of 10 milliseconds, right? So now after P1 is working, and after 5 milliseconds, P2 came. After 5 milliseconds, P2 came and it had the highest basically priority, that is the 0th priority. So P2, P4 completed for how many milliseconds? P4 completed for, that is after 2, that is 2, after then 3 milliseconds it only worked. So P4 worked for 3 milliseconds and it has 7 CPU time left. 7 CPU time left. P1 has 9 left, P4 has 7 left. And P2 then completes its all the job. So it has the highest burst time of 28 milliseconds. So P2 completed for 33 milliseconds. All the jobs it completed. Now in between, what happened? P1 has 9 milliseconds left. P4 has 7 milliseconds left. Okay. And sorry, P4 has completed its job. Sorry, P2 has completed its jobs. Now is the turn for P4 to complete. It has 7 milliseconds left, right? So P4 now comes after P2. So 33 plus 7, 40 milliseconds. So it worked for 40 milliseconds. So now P2 and P4 are over. Then P1 has how many milliseconds left? 9 milliseconds. So 40 plus 9, 49 milliseconds. Okay. Now after that again P3 came. So P3 is 3 and P4 is 4. Sorry, P5 is 4 priority. So P3 has the priority of 3 priority. So P3 completed, but it has only 2. So 49 plus 2, 51 milliseconds it came, and then it left the system. Lastly, P5 came, and it has 16 milliseconds. So it waited for 51 plus 16, 67 milliseconds, and then it left the system. Did you understand? Did you understand? টেবিলটা বুঝতে পারলে?
Yes, sir.
Okay, fine. Okay, other than Tripurari,
Yes, sir.
Pritam,
Yes, sir.
Vidisha, Rahul, everyone understood? আমি এখন একটা কোশ্চেন দিলে পারবে তো?
सर ट्राई कर लेंगे सर, दीजिए।
Okay, fine. Okay, fine. So now let us compute the whole time. So P1 has waited for 40 minus 2, that is 38 milliseconds. P2, P was, and then the priority was P2. P2 has the highest, so it has a waiting period of 0. P3 has 49 plus 12, that is around 37. And then P3 has, P4 has 33 minus 5, 28 milliseconds of waiting period, and 51 minus 9, that is for P5, it has around, what you can say, 42 milliseconds. So total average waiting time for this time is 29 milliseconds. Okay, so this is how the solution is done. So this type of questions will come in your midterm also. This type of questions will come in your semester exams also, but a little bit more complicated. Okay. So now let us go into the previous class and understand this one. So priority scheduling, we have solved on this problem and we have solved one arithmetic problem. Now comes the round robin scheduling. So what is the basically difference between the round robin scheduling and other scheduling algorithms? So in round robin scheduling, each process is given same priority in terms of time. Okay. So it is similar to the FCFS scheduling, but preemption is added to enable the system to switch between processes. So in this case, what happens? A small unit of time, so let us say time quantum or time slice is defined. So let us say in this case, the time quantum is defined as 3 milliseconds. So the CPU scheduler algorithm, kya karta hai? What it does, it has say certain P1, P2, P3 processes. What it does, it allocates 3 milliseconds to first to P1, then 3 milliseconds to P2, then 3 milliseconds to P3, or let us say in this case it is 4 milliseconds. So P1 is allocated 4 milliseconds, then P2 is allocated 4 milliseconds, then P3 is allocated 4 milliseconds, and the same thing moves round it moves. So until and unless all processes completes the job. That is what you all about round robin scheduling. So let us say process P1 is there, it has a burst time of 24 milliseconds. Process P2 is there, it has a burst time of 3 milliseconds. Process P3 is there, it's a burst time of 3 milliseconds. So initially P1 is given its quota of 4 milliseconds. So P1 is given its quota of 4 milliseconds and then it leaves the system. Okay. Then P2 is given its quota of 4 milliseconds, but it completes before. So its quota is over by 3 milliseconds. So 4 plus 3, 7 milliseconds. P3 is again given its quota of 3 milliseconds. P3 is again given its quota of 3 milliseconds and then it leaves the system, right? Since P2 and P3 are lesser times, so they leave the system. After that, P1 takes over the whole system. So average waiting time in this case for P1 waiting time is 10 minus 4, that is 6 milliseconds. For P2 it is 4 milliseconds and for P3 it is 7 milliseconds divided by 3. So it is around average waiting time is 5.66 milliseconds. Okay. Achha, Sonia came. Sonia, did you understand this problem? Did you solve this problem? The problem that was given this one?
No, sir, because I am right now in the appointment place, like the
Okay,
doctor's place.
I have told the solution to your friends. Just go, just ask them the solution is 29 milliseconds. You find it by yourself. Okay.
Okay, sir.
Okay, fine. So now, so this is the second last algorithm, that is the multi-level queue scheduling. So in the operating system, not only the user processes, there are multiple other processes that execute in the system. So there are system processes, there are interactive processes, there are interactive editing processes, there are batch processes, and there are student processes. The operating system processes, also called as processes, has highest priority over all other processes. So likewise, system processes has more priority over interactive processes. So interactive processes has more priority than interactive editing processes. Interactive editing processes has more priority over batch processes. And finally, the batch processes have more priority over student processes. All other processes have more priority over the user level processes. So what happens in this case, all the ready queue, the memory queue is divided into further multiple queues. So let us say there are 5 more queues, and each queue executes the highest level processes. So the system processes executed first, then the interactive processes, then the interactive editing processes, then the batch processes, and lastly the student processes. The problem with this kind of multi-level queue scheduling is that if the system processes are more, there will be an indefinite waiting period, okay, or there will be a starvation among all other processes. Supposedly, the system processes and interactive processes are only there. So interactive editing, batch processes and student processes, there will be indefinite waiting or starvation to get the CPU. They will never get executed. It happened for a system in this IBM system when they developed. So after, so they were executing all the systems and all the programs. So after 10 or 20 years, they found out that some of the processes that started in around 10 years earlier, they were still languishing in the systems because they didn't get the CPU, right? Because all the other processes had higher priority and they never ended their queue. So all the processes were running, and those processes which were basically lower priority, they could not run themselves in the 10 years. So this might happen. So what is the solution to this one? So there is something called the multi-level feedback queue scheduling. In the multi-level feedback queue scheduling, what happens? The multi-level feedback queue scheduling allows a process to move between queues. So supposedly, if student processes, if it waits for certain period, its priority is increased. So it can included in the batch processes. Supposedly it waits for some more time and it doesn't get the CPU. So its again priority is increased and its priority goes into the interactive editing processes. Supposedly after sometimes also it doesn't get the CPU, then its priority increases to interactive processes and lastly as the system processes. So this might happen to all the processes in the system in here or all in the queues where after a certain period of time, their priority is increased and they are allowed to move between the queues based upon the time they spend, right? So processes that waits for too long in a lower priority queue may be moved to a higher priority queue if they wait for after a certain quota of time. Okay, this you understood? What is multi-level queue scheduling? What is round robin scheduling? And what is basically multi-level feedback queue scheduling?
सर मल्टी लेवल क्यू शेड्यूलिंग सर नहीं समझे सर पूरा अच्छा से
अच्छा मल्टी-लेवल क्यू शेड्यूलिंग ओके फाइन ठीक है इन मल्टी-लेवल क्यू शेड्यूलिंग क्या होता है सो बेसिकली जो रैम होता है रैम में तो सब रेडी क्यू में जितने सारे प्रोसेसेस होते हैं ना उसमें भी कुछ सिस्टम प्रोसेस होते हैं उसको कुछ इंटरैक्टिव प्रोसेस होते हैं कुछ इंटरैक्टिव एडिटिंग प्रोसेस होते हैं कुछ बैच प्रोसेस होते हैं कुछ स्टोरेज प्रोसेस होता है तो दे डिवाइड द शेड्यूलिंग जो एल्गोरिथम जो डिजाइन करता है वो क्या करता है वो इस क्यू को डिवाइड कर देता है सेवरल क्यूज में तो सिस्टम प्रोसेस के लिए अलग क्यू हो गया इंटरैक्टिव प्रोसेस के लिए अलग क्यू हो गया इंटरैक्टिव एडिटिंग प्रोसेस के लिए अलग क्यू हो गया बैच प्रोसेस के लिए अलग क्यू हो गया स्टूडेंट प्रोसेस के लिए अलग क्यू हो गया तो सिस्टम जो प्रोसेसेस है जो ऑपरेटिंग सिस्टम को चलाते हैं उनके हाईएस्ट प्रायोरिटी है और जो स्टूडेंट प्रोसेस है उनके लोएस्ट प्रायोरिटी है ठीक है तो सिस्टम प्रोसेस को हमेशा सीपीयू मिलता रहेगा अगर वो कभी खत्म नहीं होता है तो बाकी सारे प्रोसेस जो है अंदर में जो लो लेवल क्यू में है या लो प्रायोरिटी क्यू में वो लोग हमेशा वहीं पे इंतजार करते रहेंगे राइट दे विल ऑलवेज wait for a much more amount of time. So they will never get the CPU if the system processes never stop executing. Similarly, if all the systems, above 4 systems doesn't stop executing, the students processes will never get the CPU again. So we divide the queue in level queues, right? एक सिंपल क्यू को हम लोग 5 अलग क्यू में डिवाइड कर दिया सिस्टम प्रोसेस इंटरैक्टिव एडिटिंग प्रोसेस बैच प्रोसेस और स्टूडेंट प्रोसेस ठीक है
हाँ सर
ओके और मल्टी लेवल फीडबैक एडिटिंग क्यू में क्या होता है एक प्रोसेस एक क्यू से दूसरे क्यू में जंप कर सकता है ना अच्छा
विद वेटिंग टाइम इन यस
सर बताओ व्हाट इज द क्वेश्चन
नहीं सर हम बोले तो विद वेटिंग टाइम द प्रायोरिटी ऑफ अ प्रोसेस इंक्रीजेस ना
हाँ द प्रायोरिटी इंक्रीज हो जाता है ना अच्छा माय नाउ क्वेश्चन इज दैट आई हैव गिवन यू ए वर्क राइट हु विल डू दिस जॉब before this class started so I have asked you to basically group wise you have to what you have to do group wise you have to allocate the processes right I give you this job right make a Google sheet of project group assigned to the supervisor with the student names and project titles and share it with me right ye kaun karega who will do this job Rahul,
Yes, sir.
have you made any project groups? How many project groups are there in your batch?
Sir, there is no project group yet created.
You have to create a separate project group. So in your batch, you can create two project groups. So there are, I think, 7 or 8 students, right? So you can divide it by 4, right? And you can allocate and you can ask for a faculty to be your coordinator. বুঝলে রাহুল? রাহুল বাবু,
Yes, yes, sir.
বুঝতে পারলেন আপনি?
হ্যাঁ স্যার বুঝলাম, তবে
তুমি
স্যার
ক্লাস
আপনার ভয়েসটা
রিপ্রেজেন্টেটিভ
একটু
তো? তুমি ক্লাস রিপ্রেজেন্টেটিভ তো?
ইয়েস স্যার।
তাহলে তোমাকে এই দায়িত্বটা নিতে হবে।
ওকে স্যার।
গুগল শিটে বানাতে পারো তো? রাহুল, রাহুলদা কোথায় গেল আবার? এক অদ্ভুত কেস হয়েছে। কে নেবে দায়িত্বটা? সোনিয়া আছিস? আচ্ছা আচ্ছা, রাহুল আছে। এই রাহুল, রাহুল,
হ্যাঁ স্যার, হ্যাঁ স্যার।
এই কাজটা কিন্তু আজকের মধ্যে কমপ্লিট করবে। গুগল শিটে কি থাকবে বলে দেবো আমি?
হ্যাঁ স্যার একবার বলে দিন।
তোমাদের নাম রোল নাম্বার গুলো বলো তো একটু। ওকে, এটা কে ভরে দেবে? তোমাদের জিমেল আইডিটা পাঠাও তো, বা তোমাদের
Sir,
গুগল গ্রুপের
BCA Group
মেল আইডিটা লেখো
2020.
এখানে। বিসিএ গ্রুপ কোথাও নেই।
No, sir, BCA Batch 2020 @googlegroup.com.
আচ্ছা ঠিক আছে। Please fill in the sheet with project title, project members, and faculty supervisor. Group members should not be greater than 4. Okay. এটা হয়ে গেছে, ঠিক আছে, তোমাদের সাথে শেয়ার করা আছে। এটা কতক্ষণের মধ্যে, 1 ঘন্টার মধ্যে আমাকে দিয়ে দেবে? হ্যালো, এটা হচ্ছে তোমাদের, তো এবার তো তোমরা সেকেন্ড ইয়ারে উঠে গেছো, এবার তোমাদের প্রজেক্ট করতে হবে, ছোট ছোট মাইনার প্রজেক্ট করতে হবে। তো তোমরা কি
सर
माइनर
स्किलेट्स
प्रोजेक्ट?
क्या?
स्किलेट्स अभी शायद इतना ये नहीं है, लेकिन कुछ एक प्रोजेक्ट आपको करना पड़ेगा, कुछ भी प्रोजेक्ट आपको करना पड़ेगा। You have to do some project in this batch, and you have to allocate a supervisor for that, and you have to allocate group members and all those things for that.
अच्छा ठीक है सर।
ये आज के अंदर भर जाना चाहिए, 1 घंटे के अंदर भर जाना चाहिए, ठीक है?
ठीक है सर।
ओके, थैंक यू।
স্যার প্রজেক্টের সাবজেক্টটাও আমরা চুজ করব?
হ্যাঁ, ঠিক আছে, ওকে, I am closing this one.